which are the scale. So if you go back to the open ocean, this is the scatter diagram again, wave height, wave period, joint probability for the open ocean. And if you then look at scaling the wave height by the quarter scale, scale the wave period by a half scale, the period scale goes as the square root of the length scale, so scale the wave periods by a factor of 2, scale the wave heights by a factor of 4, and then you overlay that to the open ocean, and you see that in general, apart maybe from some of the extremes up here, in general all of these dots lie on top of the measurements for the open ocean. These long period, low amplitude waves here are the swell waves coming in through the gaps. So you must be sure to ignore these when you're doing your data analysis. And sometimes these extremes become a little bit difficult because even though it's a quarter scale wave site, we have experienced there, and some of the devices that have been tested have experienced significant wave heights of 4.2 meters with individual waves of 8.3 meters in this site. So even though it's a benign site or a scale site, you still have to deal with quite severe wave conditions. But you're operating in a real sea environment, but you're operating with machines and devices which are at a scale where you can handle things. Even individual pieces of them can be lifted in and out quite easily by a small vessel. So that's the advantage of moving into this quarter scale, but you need the very special test site where the wave heights and wave periods are scaled correctly. So in terms of what's going on then with the equipment and the machinery and the conversion devices, as I said to you before, there are no commercially available wave energy devices anywhere in the world. There are one or two developers outside of Ireland who are at an advanced stage of development. But the two Irish developers, Wavebob Limited and Ocean Energy Limited, I think are as far forward in the development path as any of the others in the world. So the two companies, Wavebob and Ocean Energy, really are operating with machines which have completely different principles for converting the energy into something useful. And that's one of the issues with wave energy. There is no single idea which will be the best at converting the energy. There are many, many ideas, and there are advantages and disadvantages of them all. So if you look at the Wavebob device is really consisting of two floats. There is one large float which is below the sea level, and one float which is on the surface. So the float on the surface is toroidal in shape, and it moves up and down vertically with the wave motion. The float which is submerged hardly moves at all. It's a very large inertia and has very low movement as a result of the wave motion. So the surface float moving up and down relative to the subsurface float, this relative motion is used to convert the energy. And there is a hydraulic power pump linking these two together, so you have hydraulic rams which are used as pumps to pump oil in a circuit to generate electricity. So it's a mechanical system with the hydraulic power takeoff in terms of producing the electricity. So Wavebob have gone through the first, second, third phases of the protocol development. They've then moved into the Galway Bay test site. This is the pictures of their device at the Galway Bay scale. And it's what's called a self-reacting point absorber. As I said, it's reacting against the submerged float. And they believe that they can tune the device to be optimal in a number of wave conditions. So that's the Wavebob technology. The other technology that's being developed in Ireland is being developed by Ocean Energy Limited, called the OE Buoy. And the OE Buoy is really a floating, oscillating water column. And basically what it is, it's a very large chamber which is open to the sea, under the water, and that chamber traps a volume of air. So this is the L-shaped chamber, which is supported by a float, obviously, to keep it in place. The chamber then has an air volume above, and it's open to the sea here. So as the waves go by, the wave pressure causes the water inside to oscillate. The device itself moves, and what you find is that air is compressed and rarefied in this volume, so the air is drawn in through the turbine or blown out through the turbine, and the turbine spins to generate electricity. It's a very simple system, only one moving part, Dara will talk a little bit more about that in his presentation about the project we've been involved in recently. So it's a very simple system, a floating barge, if you like, with a chamber of air which is trapped, and that air then is blown in and out of the chamber through the air turbine, which spins to generate electricity. So they also have been working in the wave tanks with phase 1, 2 and 3, and they then have moved into the Galway Bay test site with their quarter scale model, which is 12 meters long, weighs about 30 tons, and here you can see the device being brought out of the construction yard on the transport, then lowered into the water and brought out onto the site, where most of the device is under the water. You can see the air turbine at the top here, where the air flows in and out to generate the electricity. So as I say, both of those devices have been tested at the Galway Bay test site, and in October 2008 they were on site there. And as I said to you before, the wave bob was not on site when the extreme waves occurred. Wave bob was there for a much shorter time than OE Boy. OE Boy was deployed on the site for 2.5 years, and during that time they experienced this 20-year design wave that we think of 4.2 meters in wavelength. So as I say, even in this condition, the waves are quite extreme. So both of those devices are at this phase 4 level, and they hope to move then towards the full-scale commercial operation. But unfortunately, as everywhere else in the world, I think they are having difficulty now with the financial crisis, and moving towards the next phase is proving quite difficult, both for them and for all of the developers of these types of devices. But as I say, they now are ready with quite high confidence to go towards building large machines, megawatt scale machines in the open sea. The full size of each of these devices is somewhere around 1.5 to 2 megawatts. And that would be the individual size of the machine. So I won't talk about this because Dara will talk about this during his talk. We've been using the OE Boy platform as an FP7 EU-funded project recently, using the platform as a way of undertaking research. OE had finished their development using this hull, so it was made available to us to undertake these research programs in the FP7 funded Chorus project. But as I say, Dara will talk about this during his presentation. So as I say, in terms of our development strategy in Ireland, we're at the stage where we've gone up to the quarter scale, which was envisaged. We're a little bit behind, obviously, in terms of the testing. The single devices now were expected to be in the sea by now, but as I said, there is a difficulty with the funding. Both the Ocean Energy Limited and Wavebob have received substantial funding from our government, but they're now in the process of raising the matching commercial funds to allow them to build their megawatt scale machines to go off into the sea. So the strategy to move forward then is that the government has made a commitment. Our Minister for Communications, Energy and Natural Resources, a number of years ago now, committed 26 million euros to the development of this industry. He committed substantial funds to my own centre to develop this national ocean energy test facility. He's committed funds to build an offshore test site with grid connections for full-scale devices. He's provided a grant aid support for the Irish developers, and if they get connected to the test site, he will offer them 220 euros per megawatt hour, so I should say megawatt hour, not kilowatt hour. So it's 220 euros per megawatt hour as a bonus, if you like, to support their development. So that is ongoing, and the idea is then that we will have this support in Ireland to allow the developers to go forward. So based on this, as I say, we have the development in Cork is here. This is the island of Ireland. Dublin is on this side here. This is Cork, where my own facility exists. We are going to develop into this national ocean energy test facility. We have the Galway Bay test site here, and the open sea test site with grid connection at that location. So over the next number of years, we will see a complete suite of testing facilities to support the development of this industry in Ireland. and in association with our colleagues in the Queen's University in Belfast, there will be a small-scale tidal test site in the location where the CGen machine is in Strangford Lough. So in terms of our own development in Cork, then it's becoming rather exciting. We are developing what we call the Maritime and Energy Research Campus, commercial cluster. It's a rather big mouthful, but it's been demonstrated worldwide that any way you could have clustering of research facilities and research capabilities to support the industry, then the industry is developed. So that is the idea, that we will create this cluster in Cork, which will be available then to support the development of industries into the future. And the cluster is, in terms of the support facilities, is rather unique in the world. We have a linking together of the university, which is UCC. We have the Institute of Technology in Cork. We have a place which we call the Maritime College of Ireland, the National Maritime College of Ireland. And that is a location which trains all the seafarers who drive ships and maintain ships in Ireland. So we have very big bridge simulators, very big simulation type facilities there. And uniquely, the fourth arm of this is the naval service. We have our Navy involved in this project as well, so we have a commitment, because in the long term the Navy must be involved in the security and the operation of these devices at sea. So the whole comes together in this MRC concept, which will develop in a single campus. So the idea is to create a new campus about 20 kilometers away from the university. The university is up here, the main campus of the university. Our present location for the Hydraulics Maritime Research Centre is in the Cork City location. We're transferring to this location on the seaside at Ringaskiddy. The open sea is down here, so we have a very large enclosed harbour area here in Cork, and the open sea then is through this entrance of the south. So we will have the sea directly on the outside of our facility. This is the location of the facility. The Naval Service have their main Navy base for Ireland on this island just in Ringaskiddy there. So this is the location of the naval base. This is the location of the Maritime College, the National Maritime College, which, as I say, is involved in training and simulation for seagoing activities. And this will be very important for training people in the maintenance and operation of ocean energy devices into the future. So that exists at the present time, and as I say, we will utilize the facilities of that in the support of this cluster. And the third element then is a new building which we call the Atlantic Gateway building, 4,500 square meters, a new research centre which will be constructed on the site alongside the National Maritime College, and then will rehouse my own research facilities in this new location. So the Atlantic Gateway will bring together not only my own research centre, which concentrates primarily on wave tank testing, simulation and power takeoff. It will bring together another research centre in the university which specialises in coastal planning, in GIS systems and databases and environmental modelling, and also a centre which works primarily in wind energy and are developing into the area of offshore wind. So these three research centres will come together in a single location to provide research support for the development of this ocean energy industry in the Cork area.